almost certainly yes. But is it necessary for understanding the universe? No. And I think actually from a more fundamental point of view, it's I think I might be able to argue. So one of the things that I've been interested in and been pretty surprised that I've had anything sentient to say about is the question of why does the universe exist? I didn't think that was a question that I would, I thought that was a far out there metaphysical kind of thing.
Yeah, so we're talking about randomness in the universe, and it just is becoming as if, I mean, obviously you can equate, well, everything happening on Earth is random, or the asteroid hitting Earth is random, or our extinction date is random. I mean, from a certain perspective, and this is what's going to falsify this theory no matter what, because they don't have an exact interpretation of the shelf life of the universe, etc. So they're trying to understand the evolution of our planet's evolution, and that's just not real. That's just not adequate. I mean, that's not going to be adequate for anybody.
Even the
And I think it's just going to cost a lot of money.
philosophers have stayed away from that question.
I mean, this whole idea that we're going to stick, a LIGO into the universe, this whole idea that we're going to have a LISA, whatever that stands for, gravitational, this whole idea that we're going to stick a LIGO, we're going to call it LISA, we're going to stick it into space in 20 years, and it's going to be able to, the interferometer is going to be able to test gravitational waves. And so we're going to have a more adequate understanding of the objects, the celestial objects that we're observing. We'll have a better understanding of those. And that's somehow going to help solve this evolution of our evolution problem. It's just a little bit ridiculous.
For the most part, it's such a kind of difficult to address question. But I actually think, to my great surprise, that from our physics project and so on, that it is possible to actually address that question and explain why the universe exists. And I kind of have a suspicion, I've not thought it through, I kind of have a suspicion that that explanation will eventually show you that in no meaningful sense can there be randomness underneath the universe. That is, that if there is, it's something that is necessarily irrelevant to our perception of the universe. That is, that it could be there, but it doesn't matter, because in a sense, we've already, whatever it would do, whatever extra thing it would add, is not relevant to our perception of what's going on.
So why does the universe exist? How does the irrelevance of randomness connect to the big why question of the universe?
So, I mean, why does the universe exist? Well, let's see.
And is this the only universe we got?
It's the only one. About that, I'm pretty sure.
So now, which of these topics is better to enter first? Why does the universe exist, and why you think it's the only one that exists?
Well, I think they're very closely related.
Okay.
So, I mean, the first thing, let's see. I mean, this why does the universe exist question is built on top of all these things that we've been figuring out about fundamental physics.
So they're talking about the fundamental physics says that there is one direct point in outer space, and they call it 15 billion years. So they can understand the interpretation goes, well, 1 light year, 2 light years, and then they get all the way up to 15 billion light years. And they can say that, well, there's a direct point from, the direct point that they're measuring out in space, which is 15 billion light years in the past. Of course, that's what they say. They can say that they can equate some ultra randomness, like that there is something other than randomness from that point just by having a quantum computer look at it. I'm pretty sure that's what they're saying. It's a little bit ridiculous.
Because if you want to know why the universe exists, you kind of have to know what the universe is made of. And I think let me describe a little bit about the why does the universe exist question. So the main issue is, let's say you have a model for the universe, and you say, I've got this program or something, and you run it and you make the universe. Now you say, well, how do you actually, why is that program actually running? And people say, you've got this program that makes the universe. What computer is it running on? Mm-hmm. Right? What does it mean? What actualizes something? 2 + 2 = 4, but that's different from saying there's a pile of 2 rocks, another pile of 2 rocks, and somebody moves them together and makes 4, so to speak. And so, what is it that kind of turns it from being just this formal thing to being something that is actualized? Okay, so there we have to start thinking about, well, what do we actually know about what's going on in the universe?
Again, how is that an adequate? How is saying it just doesn't seem like an adequate theory? It's never going to be an adequate theory. You can't cover the entire universe. You just can't do it. There's nothing plausible about saying that you can uh, just cover the entire universe in this theory, and then that somehow gravitational waves are going to save the theory from being inadequate. Like it'll only be, yeah, I mean, it's only going to be negligible. It's never going to have any eligibility for it. It's always going to be some scam theory. It just is.
Well, we are observers of this universe, but confusingly enough, we're part of this universe. Mm-hmm. So, in a sense, we what if we say what do we know about what's going on in the universe? Well, what we know is what sort of our consciousness records about what's going on in the universe.
Mm-hmm. And so consciousness is part of the fabric of the universe, so we're in it.
Yes, we're in it, and maybe I.
All right, I obviously couldn't get through this timely message. I meant to listen to it, but I mean, I I need to be like multitasking. I got to the main points. So yeah, complexity of the universe. Complexity of the universe basically is just talking about. Again, for some reason, I used to like this guy more, or at least in his other two interviews. Maybe I wasn't listening closely enough, or I was still blinded by quantum gravity. Um, yeah, so basically, complexity. They're uh, defining this quantum computation in this way that it is making the universe solvable. There's also another point in here. It's called what is it called? Oh yeah, the Ruliad. The Ruliad is kind of like where their cosmic background radiation begins, or their microwave background radiation in the cosmos begins. So that's like their like line, like they have quantum computation. I would imagine that circles off the universe from their point. This is 15 billion years ago, from when theoretically their Big Bang started to fit their their theory and everything. And then you have this is so outside here is like the Ruliad. I believe that's what they're calling it, is the Ruliad. And yeah, I mean, there's not much to be said other than that. Basically, quantum quantum computation just turns everything into an intelligence argument. So everything has consciousness. Everything, the atoms know what they're doing. I mean, because if you can, obviously, if the entire universe was sterile and there was no living organisms on it, you could just say, well, everything has the same exact, or even in a deterministic plane, even a deterministic universe, you could just say, well, everything is ruled by the same psyche of consciousness, or the asteroids, the planets, the clusters, all of these things are ruled by uh, the same consciousness or whatever. Since evolution on our planet did happen, then you can say that evolution is possible anywhere, and that's basically what they've done with quantum computation. So it's not that special. It's not that great. Um, I guess I don't really know what to say about it. That is nice. Again, you have to have a very optimistic view. I mean, if you're in these studies, you have to have a very optimistic view of future economics and economic collapse and extinction and all that. You have to have a very optimistic view about it. I mean, you can't say there's anything wrong with our universe or anything wrong with our planet, the state of our affairs, or anything like that. Everything is going as planned. We will make it out even better. All these huge embarkments like telescopes and interferometers in space are well worth it. Billions of dollars put into a microscope, well worth it. So yeah, it's just more. Um, it just seems like more cosmic religion. Again, if they're making predictions on like, well, when asteroids are going to hit and all that stuff, it just seems a lot less likely that we're going to die from an asteroid than we'll die from our food supply going out. And so there's like obvious notions that you can take, like, does an atom have consciousness? Well, does it really matter? And if we're talking about quantum computation, then yes, of course, every atom, everything within the boundaries of this Roolead will have consciousness, will have predictability, will have determinism. And this is dangerous for, I mean, it's dangerous to say, well, I'm going to, label something as deterministic. But if you have, I mean, if you understand what determinism is sightly, then yes, you can say, well, this is definitely a deterministic plane. Things that I can't avoid keep happening to me, or something like that. Within those boundaries, but then when you give it to the whole universe and you're just playing with those words, that's not. I mean, it's not up for debate. That's just a completely moralless, ethicless. There's no ethics, no morals, nothing of that nature. I mean, you're just saying, well, what's happening is happening. And then when you're asked a big question, like a theory of economics, well, it has to be all optimism. Or when you're asked I mean, this is like the only question asked about humans. I mean, I'm sure it wasn't, but and then all of a sudden it's all optimism. So yeah, I don't think I can get through all of this, but yeah, it's just a little bit unfortunate. Like my raspy fucking cough. But anyway, didn't mean to personalize this whole video. Yeah, I just can't. I don't know. Just the whole. I mean, it's just this whole quantum computation, quantizing everything, just quantizing everything. And again, trying to add their little theory of gravitational waves, and somehow this idea that they'll be able to precisely measure the universe better with their gravitational wave computation is just going to change everything. But it's really not. It's just there's no point in trying to find out the evolution of Earth's evolution. Like, why are they doing that? So that's my argument. Why are they doing that? Yeah, I mean, Earth's evolution, I'm sure, was hard enough to figure out. Now are supposed to figure out how Earth evolved. And that's just a little bit ridiculous. So it's a little bit ridiculous.